Hello and welcome to this topic. And this topic we are going to cover what we call storage media. We are going to start from the RAM up to the DVDs. It's your trainer, Jovan Ocheng. Now, storage media are essential components of a computer system that will provide both temporary and permanent data storage capabilities. This presentation that I'm about to give you right now will explore on various types of storage devices. That we may include the primary memory, that is the RAM and the ROM, and up to the secondary memory or the secondary storage devices such as the hard disk, the flash drives, and the optical disks. You need to know about them so far. Now we will examine how each technology will work and their specific application, advantages, and their disadvantages in our modern computing environment. Let's get to it right now. Welcome. Now, the primary memory. The primary memory will include two types of memory. That is the random access memory and the read-only memory. So the random access memory, the RAM, is the memory that is refers to as the primary memory, and it's a memory chip on the motherboard that allows the information to be stored or to be accessed in any order with equal accessibility. So when you do operating system, you are going to discover they aid in a memory management activity. They are the temporary storage. So the temporary storage in an operating system, they offer temporary storage, and the temporary storage will store operating system, application, program, and the data in a current use for quick process and access, for quick processing and access. They are also called the volatile memory. Because why are they called volatile? Because they are much faster than other type of storage, but they lose memory or they lose the data that they hold the moment the power is off, the moment you turn off the computer. So the RAM will serve as the computer working memory and will provide quick access to data and program that are currently running within the computer system. So when you turn on your computer, your operating system and other files will be loaded on the RAM. That's where they will go. They'll be loaded on the RAM and then they will be stored back into a permanent storage the moment you are finished and you are done. So it is typically to hold just temporarily for a given time, and then they are stored back to the hard disk. So when you have an operating system in a computer, it is always stored in a secondary storage, that is the hard disk, and then once it is required for use, they will be loaded to the primary memory. That is the work of the primary memory, the RAM and the ROM. So the RAM technologies, there are two types of technologies of RAM. There are two types of RAM. We have the static RAM, or some people call it the SRAM, and then we also have the dynamic RAM. Some people call it the DRAM. The static RAM will store information using what we call flip-flop circuits and will maintain the content for as long as the power is available. Once it is off, it will lose the information. And then we say the static RAM is more stable but less dense storage capacity. It has a less capacity compared to the dynamic RAM. It is commonly used for cache activity, cache memories. If you have ever heard of cache memories, it is used for cache memories where speed is critical. So that those information that have been stored for quick access are stored in the cache memory. And an example of RAM that serves that cache memory activity is the static RAM. Now the dynamic RAM. The dynamic RAM will store information as electrical charge that must be refreshed periodically. So it holds an information temporarily but will always be refreshed periodically, meaning that when we are refreshing, we are freeing up the memory. So in a dynamic RAM, higher packing density is there. There's a higher packing density than in the static RAM, and will allow more storage in the same physical space. So it will provide for more storage within the same physical space. Then the dynamic RAM will always be commonly used in the main memory due to the cost effectiveness of the dynamic RAM. So when you are performing memory management techniques in an operating system, normally the person who does that all activity is the dynamic RAM, the type of RAM called dynamic RAM. Now there's another type of primary memory called the read-only memory, and this read-only memory will always store information permanently. You can only read on that information, but you'll never write on that storage. So you'll just read. So I want to give an example by describing the moment you open your Android phone, you will see an information being displayed Android each and every time when you're opening. It's the name of your phone, maybe Infinix, and then you see Android technology. So this information is always kept on a read-only memory. It is just a primary memory within your device, but you cannot write on it. It is permanent. The information written on it is permanent. Even if the power goes off, the information will still be on it. So when you turn on power, it is activated, that memory is activated, and then the stored information that was placed inside there will be displayed. So that is the work of the read-only memory. It happens the same in the computers. For instance, when you're opening your computer, like let's say you are opening your device with the HP, so you will see the HP displaying itself, then some information. Those information that you're seeing there are stored in the read-only memory. There are types of read-only memory, and read-only memory can be non-volatile storage, meaning that they provide permanent and semi-permanent storage that retains data even when the power goes off. That is what we call non-volatile. Remember, we said the RAM is volatile, meaning that anytime power goes off, it will go. So for the read-only memory, we have it is non-volatile. Secondly, example is that it has the startup instruction. So the startup instruction are those stored essential programs, like the BIOS when you're opening your laptop or your phone. Yeah, the BIOS, which are initialized equipments, and they check for the hardware devices when it is being powered on, if you remember. We also have what we call the read-only access. Read-only access meaning that the content can be read, but you cannot be rewritten. You cannot rub it. You cannot write another type of content on it, unless you have a special type of window that you can use to erase the information, but it cannot be rewritten during the normal computer operation. Then we also have what we call the manufacturer's program. An example of a manufacturer's program is stored in a RAM. They will contain the standard processing program supplies from the manufacturer. Example, HP. So this manufacturer's program will help us to operate the personal computer. Very good. Now, which category of device are these? The hard disk and the magnetic storage. Wonderful. Thank you for that. They are categorized under what we call the secondary storage device, the magnetic storage and the hard disk. So the hard disk is a metal platter coated with a magnetic oxide, and then it can be magnetized to represent data. So that's the work of the hard disk. So as you advance, you'll see inside the hard disk the way it is. It will always have a platter and a read-write. Then we also have what we call the magnetic tape. The magnetic tape, the ones that we used long ago, those ones who were born in the 90s can remember, and in the 80s, the radio cassettes used what we call the magnetic tape. So the magnetic tape will store information in a magnetic format, and then magnetic storage it is measured by characters per inch, or bits, or BPI, bits per inch. We also have what we call the flash disk. Flash disk is a removable storage with a high capacity, and it is very portable, though vulnerable to viruses. So a hard disk and a flash disk are always vulnerable to viruses. The moment you write on it with a virus, it will interfere with the information that is in there, and it can even alter the memory and clear the memory. The same thing that is the contrary to the hard disk, the magnetic tape and the diskette. Diskette also, they use a magnetic technology, but they have what we call a flexible Mylar disk that records data as magnetized spots on a track. So contrary to them, they cannot be affected by virus, but there are technologies which are currently obsolete. They are not used currently because we have advanced. The ones that are still in use are the hard disk and the flash disk, and due to current situation, another form of storage has been introduced called the solid state. So it is going to replace the hard disk soon, and we are not going to speak of the same story again. The solid state can also be affected by the viruses. I don't know why they can, because I think it is because due to the easier way of read on write activities. So magnetic storage have evolved from the large tapes to compact flash drives. Then they have offered increasingly high capacity in small forms factor. These are what we call secondary storage devices, and they provide permanent storage, permanent data storage. So data that is stored on them is not lost, whether power is off or on. The data will never be lost as long as you've stored them there. You've saved. They will always offer permanent storage, or you decide to erase it yourself. Now, another type of technology which is still a secondary storage is what we call the optical storage technology. Optical storage technology, they will include what we call the laser technology. Laser technology will use a laser heat to hit a metallic layer on top of a disk. So those disks that you see, those CD drive and the DVD drives you see, they always have what we call a metallic layer on the disk surface. So if a laser technology, that light technology which hits that metallic mylar, then it is going to form a track, then producing some tiny spots on the disk, which will represent the data. So if you want to read the data, you are going to read on those spots that have been heated on that metallic mylar. The other type of how do we read or write on this optical technology? The optical technology, we read on or we write on them through the light technology also. They are categorized by whether the user can only read the data or can also write on the medium. We have the optical technologies that offer both read or write. So when you see DVD-RW or CD-RW, it means it is a compact disc rewritable, meaning that you can erase whatever it is in that disk and you write again in a different way. So when you see CD-RW, it is a rewritable. DVD-RW, digital versatile disk RW, meaning that you can rewrite on it. Then we also have what we call the capacity. They offer high capacity of up to 4.2 GB, and for the CD 700 GB and MBs. So they offer high substantial storage compared to traditional magnetic media. So magnetic media, that is the magnetic tape and the diskette, they have a minimum storage capacity. The hard drive and the flash drive can also offer equivalent or more storage capacity as the optical storage devices. Now, the manufacturing process, they are produced in a dust-free plant, and they can be created for both audio CD and data CD. So if you ever heard of the Blu-ray disc, those are the examples. They store information and they are kept in a dust-free environment. If you expose them to dust, they get scratches. That's why you cannot access a CD with a scratch. Now, the optical storage uses laser technology to read and write the data on a specific coated disc, and we say this coat is called a metallic mylar. This technology offers the advantage in capacity, durability, and cost effective as compared to the earlier storage devices. Now, still on the same optical technology, we have what we call the CD-ROM. The CD-ROM in full, it means the compact disc read-only memory. Most of them will always be between 606 MBs to 700 MBs. That is the storage capacity, and they offer a size of 4.7 inches in diameter. They are standardized. So these CD-ROMs, they have become prominent recently, or just a few years back. They have become prominent optical storage technology due to their capability with the audio CD manufacturing processes. This standardization has allowed for cost-effective mass production of softwares. They can store softwares, other reference materials, media contents, for instance, video music, audio music, and they are very durable. In fact, they store information in a very long period of time. The only thing that affects them is scratches when they are exposed to dust. The CD-ROM, they provide a significant leap in storage capacity compared to the floppy disk and the diskettes and even the magnetic tapes. They enable the distribution of large application and databases that previously are required for multiple diskettes. Now, the DVD technology, digital versatile discs, the DVD technology. Now, if you look at that triangle very well, this is how the DVD has been evolving. We have the dual layer technology, which is a semi-transparent gold layer that allows reading of the underlying silver layer. We also have the short wavelength laser that will enable the smaller indentation and increased storage capacity. Then we also have what we call same physical sized as the CD, as the compact disc, and they are of 4.7 inches in diameter or 0.5 thickness. Now, this digital versatile media technology represents an evolution of the optical. Actually, it's just an improvement of the compact disc. They maintain the same physical dimension with the compact disc, while dramatically they are increasing the capacity. So the capacity in an optical disc, that is the compact disc, it is very small as compared to the DVD, the digital versatile disc. DVD stores data in spiral tracks of a small indentation, and they are similar to the CDs, but they are there's some several key technological improvement there. When you look at the DVD, it's a bit darker and bluish in color as compared to the CDs. Now, the thinner, darker layer of the DVD enables dual dual layer storage, meaning that it can perform dual layer storage, effectively doubling the capacity. The laser beam can be adjusted in a DVD to different intensity so as to read either semi-transparent outer gold and the underlying silver layer. So you go and look for the difference between the two of them. Just have the CD and the DVD. You will see there's a quite difference. That being said, about the storage device, I want to thank you for being patient and going through this activity. See you in the next topic, and God bless you. Have a lovely study time.